There's a galaxy out there with something that looks like a fresh wound across it. Not a pretty spiral arm, not a dust lane, a thin, violent scar, like something cut through the galaxy and kept going. And here's the unsettling part. The leading explanation isn't a weird cloud or camera noise. It's that a black hole, something we usually imagine as trapped in a galaxy's center, may have moved through the galaxy, leaving a trail like a contrail in space. So today we're doing one thing: follow the scar and figure out what could possibly make it. JWST didn't catch a black hole moving like a spaceship. It caught the aftermath, a razor-straight scar, an enormous, approximately 200,000 light-year streak of shocked gas and newborn stars, like something plowed through a galaxy's outskirts and left a wake behind. And at the very tip of that wake sits a bright, compact source. That's when the team stopped asking, "Is this weird?" and started asking, "Is this measurable?" They used JWST's NIR spec to do the most brutal test possible. Map the motion of the gas, pixel by pixel, right at the tip. The result is the moment the story turns from theory into evidence. Across a region only about a kiloparsec wide, the gas velocity abruptly jumps by roughly 600 kilometers per second, a clean break you don't get from gentle rotation. It looks like a shock front, and when they model it, the simplest fit is a massive object moving supersonically, carving a bow shock, with an inferred speed close to 1,000 kilometers per second. That's fast enough to compress thin gas, ignite star formation, and draw a glowing line you can trace like footprints in snow. So here's the nightmare question. If that tip source really is a supermassive black hole, the kind that usually sits locked in a galaxy's core, what could possibly kick it hard enough to launch it and keep it running away? Because the answer isn't a strong wind. It's something far more violent, and it changes what we think galaxies can survive. So what could kick a supermassive black hole hard enough to rip it out of a galaxy and send it flying? There are basically two ways the universe can do something that violent. 1. A gravitational slingshot. If a galaxy has multiple giant black holes because it's been merging and swallowing neighbors, then you can get a chaotic three-body interaction. One black hole gets captured, one gets ejected, and the loser is launched like a stone from a sling. It's rare, messy, and it can produce insane speeds. But there's a second option, and it's even more disturbing. 2. A gravitational wave recoil. When two black holes merge, they don't just quietly combine, they release an enormous burst of gravitational waves. And if that wave emission isn't perfectly symmetrical, if the masses or spins are slightly uneven, the merged black hole can get a kick. A real momentum kick, like a cosmic gunshot. In extreme cases, that kick can be fast enough to escape a galaxy's core and never come back. Now here's where the JWST runaway claim becomes truly dangerous. If a black hole has been kicked out, then the galaxy's center should look wrong. Either there's no obvious central monster where one should be, or there's a second black hole still sitting there, meaning something even bigger happened. So the next question isn't, can a black hole run away? It's, what evidence would prove it's not just a weird, bright object making a pretty trail? Okay, so if this is real, what would the universe let us see? Because a runaway supermassive black hole isn't like a comet. You don't see the black hole itself, you see the damage it causes, and the light it drags with it. Here are the 3 clues that would make astronomers take the runaway idea seriously. Clue number 1, it's not sitting in the galaxy's center. A supermassive black hole normally lives exactly where the galaxy's gravity funnels everything, dead center. So if the brightest active object is clearly offset from the core, that's your first red flag. Clue number 2. It leaves a trail. A black hole can carry a small atmosphere of gas and stars bound to it, and as it plows through the galaxy, it can shock and ionize gas, lighting up a thin streak like a hot wake. Not a random cloud, a directional scar. Clue number 3. The numbers match. This is the killer test. The light from the object must have the same distance signature as the host galaxy, same redshift. Otherwise, it could just be a background quasar lined up by chance. And if it's moving fast, you'd expect velocity offsets in the emission lines that don't feel normal for a calm galactic center. Now here's the uncomfortable part. Even if you see a bright object off-center with a trail, that still isn't proof. Because the universe has a habit of faking the exact pattern you want to believe. So the next step is brutal. We have to ask what else could mimic this, and why astronomers think it doesn't. If you want to kill a runaway black hole claim, you start with the simplest explanations. Because most cosmic mysteries die right here. Alternative number 1. It's just a normal feature of the galaxy, like a dust lane or tidal stream. Galaxies that have merged can grow long, straight-looking streams of stars and gas. From the right angle, that can look like a trail. But the problem is the geometry and the energy. A dust lane is usually broader and softer. A tidal stream is usually made of stars and has a different texture. This scar looks more like a thin, energized line, something that got shocked and lit up. Alternative number 2. It's a background quasar lined up by chance. This is the classic trap. A super bright quasar far behind the galaxy happens to sit in the same direction, making it look connected. That's why the redshift test matters. If the bright object shares the host galaxy's distance signature, the random alignment escape route gets smaller. Alternative number 3. A jet or outflow from star formation carved the line. Jets can make straight structures. Outflows can create thin features. But this is where the tip becomes suspicious. A jet usually points away from a central engine. In this case, the bright compact source sits near the leading edge, like the knife at the front of the cut, not the engine back at the center. So skeptics can absolutely argue details. They should. But none of these alternatives perfectly explains the full scene. A compact, bright source, plus a long directional scar that looks shock-driven. Which means we're forced into the scarier question. If it really is a runaway black hole, what does that do to the galaxy it escaped from? Here's why astronomers care about this way more than just one weird image. A supermassive black hole isn't a decoration. It's tied to how galaxies regulate themselves. In many galaxies, the central black hole acts like a thermostat. When it feeds, it can heat gas, blow winds, and slow down star formation. When it's quiet, gas can cool and collapse into new stars. So if a galaxy loses its central black hole, or even if the black hole gets displaced for a long time, you don't just lose an object, you change the galaxy's future. It means the galaxy's core could become unusually calm or unusually chaotic, depending on what the black hole did before it left. And here's the bigger implication. If black holes can be kicked out, then some galaxies out there might look normal on the outside, but be missing the thing we assume every large galaxy has at its center. And the runaway black hole itself becomes its own kind of monster, because it can carry gas with it, feed as it travels, and light up wherever it goes. A wandering supermassive black hole could be bright for a while, then vanish into darkness once it runs out of fuel, which means the universe could be filled with these rogue black holes, and we'd only notice the rare ones caught during their visible phase. So if we found a candidate like this, the scary question isn't, is it possible? The scary question is, how common is it? So how do we actually decide if this is real? Not interesting, not plausible. Real. It comes down to two make-or-break checks. First, the trail must tell a time story. If the scar is caused by something moving, the material along it shouldn't all be the same age and behavior. You'd expect a pattern. Older regions farther back, younger activity closer to the source, like a timeline stamped into space. Second, the galaxy's center must show scars too. If a black hole was kicked out, the host galaxy should look disturbed in a way that matches a recent violent event. Merger signatures, asymmetry, unusual structure, something that explains how the heart got displaced. And if it was a three-body slingshot, there's an even wilder possibility. There could be another massive black hole still in the host, sitting closer to the core. Now here's the final twist. If future observations disprove this, we still learn something important. The universe can fake patterns that look perfect, and we get better at not being fooled. But if this holds up, then supermassive black holes always sit in the center, stops being a rule. It becomes a gamble. And somewhere out there, there may be galaxies that survived after losing their central monster, and rogue black holes drifting between galaxies, visible only when they feed. So tell me what you think. Is this a real runaway black hole, or a cosmic coincidence that just looks like a clean cut through the universe?